Well, they will do yes, sir.
Good afternoon, boss sir. Am I audible?
So we are required to move it audio.
Hello, can you hear me?
Yes, sir.
No, okay. Okay,
Yes, sir.
now I'm muted. Yes, hello everyone.
Yes, sir. So I'll start with the session.
Okay, sure.
Yes, sir. Good afternoon and a very warm welcome to all the guests and delegates. Albert Hubbard has rightly said that one machine can do the work of 50 ordinary men, but no machine can do the work of an extraordinary man. These words are very aptly describe our extraordinary esteemed guest and panelist in today's session on information technology, revered session chair Professor Sanjay Gupta, respected co-session chair Dr. Dean Pastor Aglas Jr., and our remarkable keynote speaker Dr. Utku Khose. I welcome you all to the session. I also extend a hearty welcome to all the delegates and researchers from different institutions, faculty colleagues, and dear students. We have illustrious personalities in our session for providing us with their valuable guidance on principles of information technology. I feel immense pleasure in introducing and welcoming our session chair, Professor Sanjay Gupta. Dr. Sanjay Kumar Gupta has obtained MCA and PhD in computer science from Jivaji University, Gwalior. Since then, he has donned various roles with DPI at Jabalpur MP, Employment and Training, and Rohilkhand University, Bareilly, UP, before joining Jivaji University, Gwalior. Currently, he is working as Professor of Computer Science, Director, Institute of Engineering, and Coordinator, School of Studies in Computer Science and Applications, Dean, Faculty of Engineering Sciences. He has over 24 years of teaching experience to teach graduate and postgraduate courses. Dr. Gupta, general research focused on improving software testability and maintainability of object-oriented systems. He has authored, presented 35 research papers in various journals and conferences. His research interests lie broadly in areas of IT applications, software engineering, software testability, software maintainability, design pattern of object-oriented systems. Dr. Gupta has worked as member of Executive Council, Warden of Aryabhat Hostel of Jivaji University, Gwalior. Currently, he is also in charge of Nishak Jan Parav Toksha of Jivaji University, Gwalior since August 2005. Welcome, sir. Now, it's my privilege to introduce and welcome our co-session chair, Dean Pastor Regulus Aglas Jr. Dr. Pastor Regulus Aglas Jr. is an international speaker in the discipline of computer science and information technology. He did his master's in information technology from Rizal Technological University, Philippines, and his bachelor's in computer science from University of Batangas, Philippines. Sir is a certified internal auditor. He has certification from MTA and TVET qualification and certification system. Sir is also affiliated to Computational Intelligence and Machine Learning Research Journal, Institute for Engineering Research and Publication, AMIT International Impact Factors Journal, Council of Dean and Information Technology, Philippine Society of Information Technology Educators, Philippine Computer Society, Computing Society of Philippines, City Information and Communication Technology Council, Pugar Law in Philippines. I welcome you here, sir. I feel happy to introduce and welcome our keynote speaker in the session, Dr. Utku Ghosh. Dr. Utku Ghosh received the BS degree in 2008 from Computer Education of Gazi University, Turkey, as a faculty valedictorian. He received MS degree in 2010 from Afin Otay University, Turkey, in the field of computer, and PhD degree in 2017 from Selek University, Turkey, in the field of computer engineering. Between 2009 and 2011, he has worked as a research assistant in Afcon Kopatet University. Following, he has also worked as a lecturer and vocational school vice director in the Kotep University between 2011 and 2010. As a lecturer and research center director in Uzak University between 2012 and 2017, and as an assistant professor in Suleiman Demirel University between 2017 and 2019. Currently, he is an associate professor in Demirel University, Turkey. He has more than 100 publications, including articles, authored and edited books, proceedings, and reports. He is also in editorial boards of many scientific journals and serves as one of the editors of the Biomedical and Robotics Healthcare book series by CRC Press. His research interest includes artificial intelligence, machine ethics, artificial intelligence safety, optimization, the chaos theory, distance education, e-learning, computer education, and computer science. Welcome, sir. Mark Twain has very aptly said, the secret of getting ahead is getting started. Therefore, to commence the session, I request Dr. Utku Ghosh to present his keynote in front of the August gathering. Please, sir.
Thank you very much, dear. I think my voice is hearable, and also you can see me. I would like to thank dear Professor, especially Satish Bansal, for his kind invitation and support, and also I would like to thank to everybody having great role in that event, and I would like to also send my best wishes and thanks to Prestige Institute of Management Gwalior, located in India. So let's start. I will just start the sharing of my screen. Yes, I think you are now viewing my presentation file, presentation screen. Yes. Yes, welcome to my keynote speech. Welcome to the session, dear friends, dear colleagues, and dear valuable students. My speech, my keynote speech is titled as the Explainable AI and Internet of Things, or we can say just briefly as the IoT synthesis. As you know, the field of AI has many different developments and many different innovative findings and also products, in especially within the period of so far of the 21st century. And because of the trustworthy issues, there are many different types of the research activities included under the area of the XAI, which we call as the explainable AI. And I will just give some brief informative information regarding the XAI, and we'll discuss about its possible applications in the context of IoT. Dear colleague just introduced me. I'd like to thank you for also dear Shubangi. I hope I'm spelling it right. Thanks for your kind introduction for me. As you can see, I'm affiliated with the Suleiman Demirel University as an associate professor, and I'm also affiliated with the ITMSLS Bardo University from India. And currently, I'm working as an associate professor in the Department of Computer Engineering, and my university is located in the city of Sparta. I would like to all invite you to visit our country and our city after that the issue of the COVID-19, of course, is eliminated. So you are all welcome to visit my country as well as my city and also our university, of course. I'm also looking forward to visit India as soon as possible. Yes, my presentation will be focusing on the essential information regarding what is AI. We are all knowing the essentials of the AI, but I will just pass some brief information regarding the concept of AI, and after that I will give some informative explanations regarding the XAI. I will focus on some simple applications by considering the recent literature, and after that I will discuss about the XAI and IoT synthesis, and I will end my presentation with some open problem explanations and also suggestions which are valuable for especially their students and also my colleagues interested in working in the context of AI, XAI, and XAI IoT synthesis. Yes, we already know about AI. What is AI? It's just briefly defined as the science and engineering of making intelligent machines, as defined by the Professor John McCarthy, who is the father of the concept of the AI. We know that it's somehow a simulation of humans, animals, and the nature, and it just allows us to deal with the real-world problems thanks to technology-based intelligent solutions. And because of its flexible and effective solutions, effective outcomes, we can say that it's a way for improving the effectiveness and efficiency. And because it's a very robust, strong, and flexible scientific field with lots of innovative products in terms of software and hardware side, we can say that it's the science of the present and the future. And especially after it was developed, it has just gained a rapid momentum in terms of the multidisciplinary. So we can just say that it's the multidisciplinary science aiming to provide effective and very successful results for different fields of the modern life. And that's because because of the strong mathematical and logical backgrounds, and that's actually a fear of the starting to working in the field of AI for especially beginners and students. But the mathematical and logical side of the AI is actually used by the very deeply researching in terms of the AI. But when we come to many different innovative foundations and also additional research efforts for improving the background of the AI, we just come to mathematical and logical background. But except from that, especially the 21st century caused already that the many different types of products are taking rapidly place in our modern life, and they are supporting our daily routines and also decision making. So AI has already become a common thing, but there are of course lots of discussions because of that. For example, everybody is asking that if it is a utopia or dystopia, or if it will be a technological risk or threat for the humankind. And actually it's not a stable technology because it's evolved with many different efforts by the supportive technologies. But it's actually a product by the humankind, so it can be having some errors, human errors, and also many different drawbacks, as you know. So that causes the literature of the AI to be improved day by day by solving open problems, as you know. But the discussion seems not to be stopped because the future of the AI is also having some blurred sides. So we are all discussing that if it will be a cause of extinction for the humankind, or if it will be a technological risk. It will be having some ethical considerations in terms of the automated autonomous problems, solutions especially. So it has just causes us to consider some different types of topics under the field of the AI. And as one of them, as among many different types of topics included under the field of the AI, explainable AI is one of the most trendiest topics. And as you know, the traditional AI solutions are widely used in all fields of the modern life, and these fields include many critical ones. For example, we can just talk about the medical healthcare, and also in terms of the, for example, education. You can even be using the AI, or considering the robotic developments, or maybe space-oriented research, as you know recently, or hear recently from the developments by the SpaceX, and also the many different research efforts leading to humankind to travel to even Mars, for example. But all of these fields are critical, and by considering especially the COVID-19, we can be saying that the healthcare is very critical field. It was already critical, but it has gained more and more critical feature as a result of the massive issue of the COVID-19. So we can say that the technological side of such fields, and also the way of the AI to be applied in such critical fields, is very important. And of course, especially for example, healthcare and medical is a critical field because it affects the way of the human life. It affects our well-being eventually. So even if it's deep learning or the traditional machine learning, today's advanced techniques are generally black box. Earlier, we were using traditional machine learning methods to solve some simple problems which are not requiring, or were not requiring too much amount of data, for example. But when we talk about today's advanced problems, we deal with the big data, for example, or many other different solution scenarios, as you know. So we just reach to more parameters, and even hyper parameters, considering the deep learning. As you know, the deep learning is an advanced mode of the machine learning. It includes many different advanced neural network models. For now, we will all see in the future if there will be additional techniques or other models considering the deep learning. But when we just talk about today, just maybe talk about for the last 4 years, maybe for 5 years, we can say that the deep learning has gained important momentum, and provided many effective and successful solutions for many fields, including the medical, for example. But these models, these successful models, are just a black box, which means we should be trusting to such systems, intelligent systems, without having anxieties regarding their solutions or decision makings, because we are not seeing their exact mechanism to how they have reached to their decision makings or outputs by considering the inputs, for example. So we should be considering somehow some additional efforts to make them more transparent to the human side, in order to ensure that they are, yes, trustable, they have some trustworthy level, so we can be trusting about their future decision makings, for example, by not having any anxieties regarding any errors in terms of their solution mechanism, for example, or at least we can see some drawbacks or some errors when they are showing them, so we can have some precautions to make them fix it, for example. But for talking about the deep learning, it's now not too much possible with default setups of the deep learning models. So there's a need for interpretability. Actually, the traditional machine learning algorithms like decision trees, or maybe multi-layer perceptron models having a few maybe perceptrons, artificial neurons, and also maybe some rule-based systems like fuzzy logic or Bayesian reasoning models, for example, they are just have some transparent mechanisms which we can use some certain parameters coming from their algorithms to explain that, yes, that system has just used that inputs to reach that outputs. So we can be understanding that, yes, the input has solved effectively and in a trustable way to reach to the related output. But when we have hyperparameters, when we have the deep learning models, we should be needing additional efforts to make them transparent, which means to make them interpretable. That can be achieved by extending rule-based or expert systems-based oriented models. So we just reach the combination of that, all of these efforts, and we just call the new research area as the explainable AI, or we can just say XAI as a very trendy and remarkable topic under the field of AI that causes us to have additional efforts or components to make our black box, especially black box systems, to become transparent to the human side, so they become human compatible intelligence systems. When we take a look at especially to the recent literature, you can see that starting from around 2012, you can see, or 2012, we can see that there's a great improve or increase in terms of the scientific publications when we search for the keywords of interpretable AI or XAI or explainable artificial intelligence, as you can see. When we come to 2019 and this year, for example, we can see there are many different scientific publications for especially, for example, medical field, and also considering the other fields like business or education, for example, we can be seeing many different types of applications done with the support of the XAI to make their systems more understandable and more explainable at the human side. So when we compare today's default models, we can say that they are just reached to decision or recommendation by running some machine learning process, as you can see, and by using the training data as the input to reach to a learned function eventually. So we cannot ask that why did you do that, or why not something else, or we cannot be sure about when that system fail and when we can be trusting such systems. So because we are not seeing exact mechanisms and we just see a black box system, we cannot say that how do we can correct an error if such systems make errors in terms of the future data, for example. But when we use the XAI, we just have some additional components, not just building a totally new model, but integrating something to the already known models like deep learning models or other machine learning based systems. We just reach to an explanation interface, which can be also examined under the field of the human-computer interaction. So thanks to an explainable or explanation interface, we can ask all of these questions to be sure about trust level of our intelligence system. So the XAI is not just some mathematical or logical efforts to make our system transparent to the human side. It includes the asking questions about which details we will be needing to make our system more explainable, or why we are needing such XAI components. What are our reasons to make our system explainable? For example, in terms of the medical, we should be totally needing explainable AI, because in terms of, for example, cancer diagnosis, we should be having a trustworthy level hitting model to be sure about certain decision makings about a critical disease, which is cancer. So we should be having some careful details to make our system explainable, and we should be having certain reasons to make our system XAI. And also, when we use different types of techniques, we have somehow different types of transparency level. Actually, deep learning models do not have such a high level of transparency. They are black box. But in some techniques, as I've said in the previous slides, some techniques may include some transparency levels. So that's changed the way of the transparency methods we can be adding to the intelligence system. And also the scope is very important. For example, who will be viewing our system to make to be or understanding its capabilities or explainable features. For example, considering for example, doctors, we should be giving more efforts to give some technical explanations to the input and output correlations, maybe. Or or in terms of talking about the medical image, for example, we should be having enough explainable interface, like a doctor is doing while he or she is viewing a X-ray paper or other MR image data, for example, and as like doing that, hitting the exact regions over the medical image data, we should be having the necessary XAI components to make some explainable regions available over the medical image data, for example. So the scope is very important when we talk about all of these explainable interface and additional efforts to add components to the models we are already using for our target problem. And when we reach to the user side, starting from the AI model, there is the human-computer interaction side. Because of that, we should be considering the usability or maybe accessibility features. And we should be evaluating the models from the human side, user side feedback, for example. So the human factor is very important when we talk about the developments of XAI. Not only technical foundations, evaluations, but we should be having also additional evaluation efforts, including the active role of the human side or users briefly. So when we take a conceptual, slightly deeper look at to the XAI, we can say that, for example, you can be using some rules to make your system more understandable from the human side. That's actually done in terms of the rule-based techniques. So that means simulatability, for example. But if you have slightly a black box like model, like considering especially rule-based systems, again, you may be having some additional human side parameters and also additional rules to make some outputs more explainable to the human side. For example, some parameters, some values may be understandable or meaningful for your machine learning model, but that's not always possible that the human side is also understanding such parameters, but we should be having some additional parameters to make the parameters of the algorithm to be more understandable in terms of the real world or the human side. So that becomes decomposability. And also, we can sometimes have more abstract types use of the rules to make our systems parameters more opaque to the human side. But we already know about the way of the parameters, of course, but because of some development or computer programming efforts, we just make our system more transparent in terms of like talking in terms of some sentences and also some grammatical words. So that means algorithmic transparency. So we can be using one of these methods, or we just can be combining all of these three factors to make our systems more explainable. And the explainable for especially black box models includes many different types of explanations. You may be just using some text explanations, of course, or maybe using some local explanations, which means using some specific explanations for some specific parameters while your system is running throughout the training, for example. Or maybe you can be just using some explanations by using some examples. When your system reaches to some decision making about maybe a cancer diagnosis, you can be using an additional example from the human side, for example, like saying that look at both of these findings, that is from the machine learning or deep learning system, black box system, and that is from the doctor blah 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 findings for the real sample. So it's very similar, and the way of the diagnosing is very similar. So because I have reached to that decision because of the other sample by the real doctor, for example. And also you can be using some feature relevance, or maybe you can be use additional algorithms to make some a high number of parameters to be decreased to some simple way of explaining your model, or that's a better way to make everything explainable. You can be using the visualization, like the ones used in especially hybrid models for explaining black box models. You can be adding some decision trees or KNN or maybe rule-based learning systems to already trained system. And also you can be using additional layers, for example, in terms of like we are using a CNN, you can be use additional layers except from the combinational layer or pooling layer. So you can be making your the output image to be more visible in terms of heat mappings, which means the attention maps in terms of the XAI. So you can be reaching such visualization at the end, and your system can be saying that yes, there's a duck inside the input image. And because I have looked at to that regions, like the red regions, for example, especially like looking at the ears and also to the nose of the dog, so it explains that I have reached to that decision of there is a dog inside the photo. So because I have seen such regions, for example, so we can be saying that yes, that system has looked at to true regions of the photo to see that there is a dog inside that input photo. And there is another sample, as you can see, that such system has also looked at to the legs or the body of the dog, as you can see, but the more intense consideration have given to the head of the dog, and so that system can be trustable in terms of making decision makings for the input image. And also there are different types of methods. I have not explained them in detail in my presentation because such things require more hours or maybe a months long lecture to explain everything in detail. So I have given some examples, as you can see. For example, there is another method to make image data explainable. For example, in such input data, the system can be saying that, yes, there is a cat and there is a dog. So there is two different components or objects inside the photo. So I am classifying them in terms of pixels colored with different color levels. As you can see, the cat is viewed with the more green-like levels of color, as you can see, and the more red-like levels of color means that there is a dog inside the photo. And also in terms of using hyperparameters, some additional methods just causes to that's the resulting image, like using generative adversarial networks, for example. You can be also reaching to some atomic level of representations of the resulting image to see that yes, our system is using true ways of pixels or image to reach to a bigger side of the picture, for example. You can be take a look at to the deeper side details of your bigger picture, like using additional efforts. And another remarkable explainable site is the LIME. It allows you to use some probabilities while your system is reaching to some decision makings, and with using some region site visualizations for your input image, as you can see. Like, for example, like taking a look at to these regions, that system says that there's an electric guitar with the probability of 32. And there's also an acoustic guitar with another probability of 24. So I have taken a look at to these regions. I have detected these sites. So I have decided that there is an acoustic guitar. By combining both of these results, we can be saying that yes, the system is looking at the true sites of the photo, true pixels or regions of the photo. So it has somehow seems like lower values actually for now, but we can be saying that yes, it's actually has detected some guitar inside the photo, for example. That's the use of the LIME, a method for making black box systems explainable, dear friends. Yes, there are different types of transparency levels or efforts for making different techniques explainable. As you can see, there is a sample for the linear regression, or for decision tree, you can be use somehow numerical values coming from the root regions of the tree to the decision making leaf of the tree. So you can be using these numerical values and the flow of the tree rows maybe, or the three components, for example. So maybe thinking about the KNN algorithm, you can be using different types of algorithmic transparency. And these are just sample visualization which are coming from a very remarkable publication. I will be giving information about it at the end of my presentation. So just take a look at that publication of for starting to learning something about XAI. Yes, when we talk about some applications, you can take a look at especially nature-based journals. For example, there is a MR-based, CT scan-based diagnosis for the intracranial hemorrhage from small data sets. That's the CT scan, which is coming as an input to our deep learning model. And at the end, that system just applies an attention map oriented layer before reaching to decision making. So that system just shows us how it has reached to the related decisions by taking a look at which sides of the CT scans. As you can see, there is the heat maps in the resulting image. Not only using the decision makings with numerical values maybe coming from the output layers, but also using some explanation supported image. That system explains us how it has reached to decision making about intracranial hemorrhage. And also, if you are using a traditional multi-layer perceptron, for example, you can be using layer-wise relevance propagation, which causes many numbers of weights. As you know, the weights are just explaining sites or parameters to explain how your multi-layer perceptron neural network model reached to output values by considering the input values, for example. But there are many complexity of the weights. You cannot be reaching to a resulting mathematical model. If we would have making that, there would have never been needing for reuse of such models, of course. But if you are using a layer-wise relevance propagation, you can be just decreasing the complexity level of the weights, so reaching to somehow some explanation levels for your input parameters. For example, I don't know what is the result here, but considering different types of outputs, I think, or depending on the prediction process, our system just maybe using a visualization like something like that, a graphical view for the human side, and showing that which input has the more intensity in terms of the decision making by using somehow some graphical views like that, for example. But of course, that's the resulting image is done thanks to the layer-wise relevance propagation and its numerical values coming from the combinations of the remarkable weight values. That's a sample from the Nature Communications. As you can see, that's from the publication from this year. And also a 2-year-old publication is a simpler way of using the explainable AI. As you can see, it's from a proceeding. It's just a medical diagnosis for the, for example, what was that? Chronic kidney disease. Yes, that was about the chronic kidney disease, and it uses a decision tree, and by using somehow additional parameters and using some input values, it is just using that because of the hemoglobin test, because of the red blood cell count test, and because of blah blah such inputs, I have reached to decision making of that. There is a CKD detected for the input parameters of the diagnosis operation, for example. And it also has some additional visualization, or we can just say an additional interface to be used by doctors, so they can be testing different parameters to make the explainable side of the system more trustable. When the doctors take a look at to its results, they can be saying that yes, like I am doing, it has just uses such parameters, and because of the operator site and the related border values, it has reached to the confidence value about the CKD, for example. And another two samples. There are many other samples, but you are all free to search over the Google Scholar or maybe Web of Science to reach to many other samples. For example, there is another one from the arXiv. I don't know if it has already been published for now, but it says just using some gait recognition, and it allows the already obtained time series to become explainable by using different color levels to support the CNN system to make predictions in terms of clinical gait analysis, for example. And also from the PLOS Computational Biology Journal, you can be seeing that there is an identification of biologically relevant gain expression patterns, for example. And by using such visualization, it just uses an XAI to make the trust level of the system more transparent to the human side. Yes, when that's the way of the making the machine learning system explainable. But when we consider the IoT systems, as you already know, there's a great popularity of IoT systems, and for the near future, we will be all surrounded by the IoT systems, including many daily life routines and tasks to be supported by sensors and also digital systems in terms of the digital transformation. And because of that COVID-19 period, because of having some physical distance, actually, such systems will be very critical and useful, and they have even already gained more momentum after the detection of the COVID-19 massively. So we can be consider the way of the trust level of such systems, of course, when we combine XAI and IoT in terms of somehow a synthesis for them. For example, there is the ambient intelligence. There is a concept, there's a new concept of AI. It's not a very new concept actually, but it has been gaining more and more popularity, like a blockchain is gaining popularity, although it has developed for a while before the rise of the Bitcoin, and because of the Bitcoin, it has gained more popularity after later some time after the development of the actual foundations of the blockchain. And the ambient intelligence is somehow a topical scope of the IoT and AI combination, and it says that the future or the near future maybe will be all with the common daily life objects covering all of our lives, to control our medical state, to control the state of our homes, and to control everything, covering the topic of the smart cities, for example, smart cities, smart campus, or smart home, and many such things, including wearables, smartwatches, and wearable things, for example, are depending on the way of the ambient intelligence. Ambient intelligence means the software side of such IoT systems to ensure the related intelligent mechanisms in terms of software background, for example. And that is actually another requirement for the XAI usage, for making our daily life objects more trustable. Like, for example, just think about a medical sensor while you are using your toilet, or while you are washing your hands, and while you are walking just inside your home, there will be some sensors and also some wearables, maybe a smartwatch and also maybe a jacket or t-shirt, and it will be reaching to some decision makings about your medical state. But how we will be ensure that they are trustable in terms of making decision making? maybe they will be causing some problems, causing the call of an ambulance while you are very strong and healthy, and taking you to the hospital to make some checkups, and maybe to make some additional operations, causing your already normal health to become worse. So we should be needing integration of XAI to the IoT-based systems. Even
Sir,
IoT systems.
sir,
Okay,
yes, sir.
sorry.
So sorry to interrupt you, but due to paucity of time, it would be great of you if you could just short the presentation.
Okay, sure. Just around 2 or 3 minutes. Yes.
Yes.
Yes. Thank you very much. And even IoT systems will need explainable views for the human side. The more IoT used, the more cyber and ethical angsties will be rising, dear friends. So we will be using the XAI to make them more compatible with the cybersecurity even, and also ethical angsties. And so there will be always need for XAI IoT synthesis. Usability and hardware components and many cybersecurity oriented things should be included in the synthesis of XAI IoT. Of course, there are some things to be considered. The target problem should be important, the accessibility, data analytics, data security, interaction in IoT devices. Of course, interaction among them should be explainable for the human side, and the human side should be considered, because the human's errors will be very critical if you consider the XAI and their trust level, because if there will be a human error in even XAI, they will become again not trustable intelligence systems. And if we want to use a flow, for example, the data from sensors or other devices will be processing maybe inside the IoT and inferencing through the AI to make decision making. So we should be locating then XAI evaluation to make them more explainable to the human side. So after that, the actuators and feedback values will be giving to human side, and maybe they will be coming back to the again to be a data from the sensors or other devices to make a routine iterative process in terms of IoT. Yes, I am finishing my presentation. Of course, there will be open problems. For example, we should be considering the target user's characteristics and the way of the data and bias, for example. And we should be discussing about which techniques to be combined for explainability. The target problem is also important, and performance or optimization for XAI IoT synthesis will be very critical. Of course, the user experience, transparency levels, cyber security, ethical issues, and even societal impacts of such synthesis and use of XAI will be very critical. And software-hardware combination, of course, always causes some drawbacks and maybe bugs to be raised. So we should be considering such open problems for further research efforts. And my suggestions for especially dear valuable student friends, also especially colleagues, just learn about the philosophy of AI, not only the technical side, but philosophy of AI will be very essential for the future. Also learn algorithmic details of AI techniques and write your codes manually at first if you are a beginner. Not use directly, for example, Python libraries, but write your codes manually to make a good start to logical background of AI. Also, you can be learning about XAI, IoT, and XAI IoT collaboration publications, and also learn about hybrid models, that is the future of AI and IoT. Learn about data science, statistics, mathematics, and logics on the background. Join to such events, such a valuable grid events, training programs, and online programs. Read both about publications about AI and XAI, but also read about blogs or popular science articles, maybe from the web, to ensure a balance between the technical things and popular science-oriented foundations and news about the recent developments covering the world, for example. And eventually, you can be tracking famous scientists and famous events to be more understanding about the recent developments. Yes, thank you very much, dear friends. Sorry for taking too much time, but as my final words, you can take a look at that very nice publication, a majority of the images and explanations from the inside my presentation are from that publication from the Information Fusion Journal. So you can take a fresh start to the XAI, and after that you can be reaching to synthesis of XAI and IoT. Yes, thank you very much. If you have any questions, I can be taking them. Thank you very much.
Thank you so much, sir. Sir, thank you so much for sharing your profound knowledge with us. Now, just Dean Pastor Reglos, our co-session chair, has just joined, so it would be my honor to just give a brief introduction again of this, sir. So, Dr. Pastor Reglos Arkles Jr. is an international speaker in the discipline of computer science and information technology. He did his master's in the IT from Rizal Technological University, Philippines, and his bachelor's in computer science from the University of Batangas, Philippines. Sir is a certified internal auditor. He has certification from MTA and TVT qualification and certification system. Sir is also affiliated to Computational Intelligence and Machine Learning Research General, Institute for Engineering Research and Publication, AMET International Impact Factors Journal, Council of Dean in Information Technology, Philippine Society of Information Technology Educators, Philippine Computer Society, Computing Society of the Philippines, City Information and Communication Technology Council, Law in Philippines. Welcome, sir. So now I would just take permission from the session, co-session chair and the keynote speaker. So we could just start the session, sir. So shall we start?
Yeah.
You must. Thank you, sir. So before proceeding further, before starting with the paper presentation, I would like to announce that each presenter will get 10 minutes for the presentation of the research paper and 2 minutes for the question answer round. So now I would just like to call Shashi Sharma and Soma Kuwawat for the presentation. Shashi Sharma, you could present your presentation.
Yes, good afternoon, ma'am. Yes, ma'am. Ma'am, I am ready to.
Yes, sure, ma'am. You could start the presentation.
Just with them.
Ma'am, is it visible?
Yes, ma'am.
Okay, ma'am. Okay. Good afternoon, respected sir or ma'am. I am Shashi Sharma, research scholar under the guidance of Dr. Soma Kumawat and Professor Kumkum Garg, affiliated to Bharatiya Skill Development University, Jaipur, Rajasthan. Introduction. Prediction of and my topic is machine learning techniques, a review of predicting students' performance. Introduction. According to my topic, prediction of student performance becomes more difficult due to the large data in education system. So nowadays, mainly machine learning techniques are used to make improvement in their system. So by using these techniques, we help to students in improving their performance. These are keywords for my paper: machine learning, student performance, prediction, and classification. This paper focus on finding factors that affects the student performance. Also find the prediction methods is mostly used for research. Now my topic is related to machine learning. So machine learning, what is machine learning? Machine learning is an application of artificial intelligence that provides system the ability to automatically learn and improve performance from experience without being explicitly programmed. The main aim of the machine learning is to enable the computers to learn automatically without human interference or help and regulate accordingly. Ways of machine learning. Machine learning is categorized in two ways, supervised learning and unsupervised learning. Supervised learning is the method of machine learning which involves dealing with label data. Means machine learning algorithms are used label data so that a certain pattern or function can be gathered from that data. Unsupervised learning, in this algorithm, the program is given a set of data and must find patterns or relationship in between. There are no label data or label data. Okay, 1 second. Start my video. Okay. Actually, this paper used only classification methods, which is part of supervised algorithm only. Next. Okay. Behind of this review is to find the suitable attributes and methods to fulfill the gaps in the existing research. The goal of the review of the literature in current fields is to support the proposed research questions for structuring the RQ. We consist of population like university and institutions. Intervention means methods for prediction. Outcome means accuracy and all other factors. Context means primary studies, questionnaire and experiments. So the research question for this study are: what are the important features used for prediction of student performance, and what are the suitable prediction methods for student performance? Important attributes used in predicting students performance. Basically, this review is used to find out the related attributes to which is used in predicting student performance. So some attributes which are frequently used, these are demographic, internal assessment, cumulative grade point average means CGPA, external assessments, and psychometric factor. Demographic means demographic consists of age or age, gender, or family background. Internal assessment means like assignment marks, attendance, QAs or lab marks. And psychometric factor means student student behavior or student behavior. The prediction methods for student performance, based on the literature view, it is concluded that the selected ML algorithms are used for research work. So the criteria for selection of machine learning methods is based on suitability and scope of the problem as defined. Based on the criteria, the following machine learning algorithms are selected: naive Bayes, k-nearest neighbor, support vector machine, decision tree, neural network. These are the prediction results which is used in different research papers with their accuracy. Here we have used five classification methods: support vector machine, naive Bayes, k-nearest neighbor, neural network, and decision tree. Finding of the study and discussion. From this study we have we have concluded that this analysis is based on previous published work related to student performance. It is also find the prediction method which are used in previous studies. From these five algorithms, decision tree has achieved highest accuracy by 96.5%, followed by neural network. The accuracy of prediction methods is depending on the attributes that were taken for prediction. And in the through this review, there are lots of software tool, VIII, R, RapidMiner, MATLAB, Orange, etc. have been used for this prediction. Conclusion: student performance prediction is very useful to help students, teachers, and learners improving teaching and learning process. Most of the researchers have used CGPA, internal and external assessment in data sets. Mainly we have used five classification methods: Naive Bayes, neural network, decision tree, K nearest neighbor, and support vector machine. This research will help the education system to improve students' performance. Also, this research helps to other researchers to select important attributes and methods for their research in same field. Thank you.
Now anyone can ask questions. Okay, I would like to ask one question.
Yes.
That you have chosen several machine learning techniques
Yes,
to
sir.
drive the data,
Yes, sir.
right?
Yes, sir.
Or you have taken this data from somewhere else.
Yes, sir. And this is review paper, and I have read approximately 50 review papers. From that papers, we have find out these.
So how you have compiled this data?
Means, sir? Sir, actually, this is only based on previous work or previous review papers that other researchers have used their papers accurate means results.
No, it's all right. It's all right. But
Yes.
you have collected in the same form this data in other papers, or you have found it in some other form, you have compiled it.
Yes, sir. I have read and I have collected all the attributes from other papers that what are the attributes they have used, and after that we have compared that attributes according to the accuracy of the different papers.
No, you are not getting my point.
Yes, sir. I have not. Right now, I am not means not compiled.
You have not contributed to drive this data anyway.
Yes, sir. Only collected, and I have compared only those results, and I have collected only the attributes that are used in different papers, and collected means and I collected that methods that are frequently used in other papers. Means what are the methods basically used in this field.
So how can you ensure this whatever you have collected that is true as per your work, as you are saying that this will enhance the performance of a student? How can you ensure?
So presently, I have I have read those papers, and according to that, I have means now I will start my own own data and execution process.
Okay, okay.
Any
Anyone
other
else?
questions? Yeah. Any other questions? Okay, since no questions, so we'll move ahead. And now I would like to call our next presenter, Mr. N.S. Vaidya. Mr. N.S. Vaidya. Ms. Shashi Sharma, can you just please stop the screen sharing? Ms. Shashi Sharma, can you hear me?
Okay.
Okay, so I would like to call the next presenter, NS Vaidya, Mr. NS Vaidya.
Good afternoon, everyone.
Good afternoon, NS Vaidya. You could just share your screen.
Can you see my screen, ma'am?
Yes, yes.
Okay. Good afternoon, everyone. My name is Professor N.S. Vaidya, and from CSMSS Chhatrapati Shahu College of Engineering, Aurangabad. And today's paper of like my topic is like arm-based invention in vehicle mobility and atomization using artificial intelligence. So these are the overview of today's presentation. One is necessity, introduction, literature survey, then comparison of proposed system with the existing system, system development, then selection and specification of components, flowchart, circuit diagram, and performance analysis. So in India, like car stolen or accident happens, and so many things bad things where happens due to lack of data or like lack of smartness in the vehicle. So in my project or my topic is based on the smart vehicle using artificial intelligence. So auto door lock mechanical system easily break with the duplicate key if the existing system is there. Then traffic rule is to wear the seat belt. As in India, so many people are not following the traffic rules. Again, in heavy traffic, front back dash is there. Then engine temperature increases. It won't be it is very harmful for the engine. Again, to save the battery, auto switch on and off light is not there. So all those things need to okay, and for that we need to system like this ARM7 based evaluation in car using artificial intelligence. And most of the stolen car in India, like the data is in front of you. So my topic is the system is ARM7 based system. Fingerprint sensor are used to open as well as start the vehicle. AI is used to allow cars to navigate through traffic and deal with complex situation. In addition, combine AI software and other IoT sensors such as cameras make it easier to ensure proper and safe driving. A temperature sensor is used to detect engine temperature. Light sensor is used to switch on headlight at night automatically. Proximity sensor are used to for driver as well as the driver side seat belt wearing information. Ultrasonic sensor is used to detect front obstacle and back side, especially at the time of vehicle parking. Micro serial data card reader is used to work as a black box of the vehicle, where whenever accident happen in it can give all the last information which is stored in that memory card to the investigator, which is easy to detect the cause of accident. The smartness of this vehicle is to tell all the information sensor output data audibly to the vehicle owner or driver and driver side seat passenger. There are mainly three unit: GSM modem, GPS, and ARM7 unit. GSM modem can be configured by standard GSM at command set for sending and receiving SMS and getting modern like modem status. And also by chance if vehicle stolen, then send information of car location through the GSM and GPS. So these are the literature survey. These are the papers that I refer. According to the variety of vehicle, different technique are designed to control the car and its atomization. So survey number 1, an integrated architecture for future car generation, as per the paper published by Roman. The DCOS, distributed electronic control of system technique, is used, which use federated system have been preferred for ultra dependent applications. Again, in survey number 2, that automated vehicle control system, as per the paper published by Parekh and his colleagues, this system is used only for two-wheeler with 80486 chip for control unit. Again, in survey number 3, implementation of CAN bus in an autonomous all. So terrain vehicle, as per the paper published by the Sunil Kumar, the this system is designed with the using Renesas high cost processor and designed for luxurious car like Honda. The controller or network bus is used to control all the functions. These are the survey number 4 and survey number 5. So in this survey, I conclude that nobody is design a car which is having a simple and usable function and which is cheaper for middle class car. And I prefer the paper number 3. So this is comparison, like population of India is approximately 130 crore. In between, the 50% are the middle class which are not capable of driving luxurious car, or who are using basic model like Alto K10, Alto 800, Maruti 800, Swift i10, and 90% below mentioned feature are not available in the car. Like seat belt indication, front and back indication, thumb start, light sensor, black box, temperature sensor, and GSM and GIPS. So this comparison made on the basis of different car showroom visit. These are blocks of the paper or like the system development. So ARM7 is the heart of the system, which is require a power supply, and all these are the sensors like fingerprint sensor, thermocouple module, car engine temperature for car engine temperature, then ultrasonic sensor for front and back obstacle, audio player for audible information, light sensor for headlight, a GSM GPS module for car tracking in case of car stolen, and proximity sensor for seat belt wearing. All these things are connected to the ARM7 through artificial intelligence. So these are the specifications of the component which is used in the project or like the paper. This is nothing but the LPC2148. This is nothing but the thermocouple, fingerprint module, audio card, proximity sensor, ultrasonic sensor, and GPS module. So the flowchart of fingerprint, how fingerprint module is work. So if we check from the start, if somebody or like the car owner try to open the car with the help of using fingerprint, if the fingerprint is matched with the fingerprint which is already stored in the car memory, then car door is open. If no, then again it will go to the start. And if car is open, then again it will check the fingerprint match. If fingerprint match, then car is start with the help of using fingerprint. And if the fingerprint doesn't match, then give audible information that you are not the car owner, you are not the car owner. This is the flowchart of proximity sensor. When system check if the person is on the seat, and if the person is on seat, then if yes, then if that person is wearing the seat belt, no, then give audible information to the driver or passenger, please wear the seat belt. If the driver is wearing the seat belt, then stop the sensor node. Then again, this is the flowchart of LDR module. If light is there, like check whether the light incident on LDR. If yes, then switch off headlight. If light doesn't incident on the LDR, then switch on the headlight. This is the flow chart of thermocouple module. If the engine temperature is exceed 200 degrees Celsius, then audible information is given to the driver that engine temperature exceeds 200 degrees Celsius. This is the flow chart of ultrasonic module. If check obstacle on front and back side, minimum 5 mm to 5 feet. If there is an obstacle, then give audible information to the driver or like the passenger that there is an obstacle front or back. So GSM and GPS module, how GSM and GPS module is, if car is stolen, then yes, if the car is stolen, then message sent to the car owner with car location. And if car is not stolen, then continuous check GSM and GPS data. So car stolen means what? If somebody breaks the glass of door, if somebody try to breaks the sensor of the door, then and then only this will happen. These are the performance analysis of the ultrasonic sensor. This is the light dependent resistor. If the illumination lux increases, then resistance decreases and voltage also increases. Due to voltage increase and resistance decrease, light is on. This is the performance analysis of proximity sensor. If obstacle is there, then output voltage is 5 volt, and if obstacle not detect, then output voltage is 0 volt. This is the performance analysis of thermocouple. How temperature increases and how output voltage of thermocouple shows in voltage. The result of this study demonstrate that as the system can avoid cost of reviewing, it is more flexible and suggests a low installation cost. The effective communication and monitoring device will avoid losses compared to the existing monitoring system, and develop system as a simpler structure and come with the lower cost. If we consider the artificial intelligence, then artificial intelligence is demonstrated by machines, unlike the natural intelligence displayed by human and animals. Leading AI textbook define the field as the study of intelligent agent. Any device that perceive its environment and describe machine that mimic cognitive function that human associated with the human mind, such as learning and problem solving. Machine become increasingly capable. Tasks considered to require intelligence are often removed from the definition of AI, phenomena known as the AI effect. Then artificial intelligence and self-driving car are often complementary topic in technology. Simply put, you can really discuss one without the other. Though AI is being implemented at rapid speed in a variety of sector, the way in which it's being used in automotive industry is a hot button issue right now. So this is all about the presentation of mine. These are the references which I used in my papers. Thank you.
Okay. Any questions?
NS, am I audible?
Yes, yes, sir.
That is basically related to your self-driving car, or just a different thing?
Sir, it is not as compared to the self-driving car. It is a smart car actually. Smart car by using artificial intelligence. Smartly, it can be give information to the car owner or driver that please wear the seat belt, your temperature is exceed, or your car is stolen, or something like that, whatever the information I have given.
So it provides the security, it means.
Yes, yes, sir. Yes, sir.
So in that case, you mentioned it also reduce the cost of car.
Yes, sir, definitely. Actually,
How?
the cost of whatever the sensors or whatever the technology is used, which is only near about 5 to 10,000. And if we implement these things in the car, or like if suppose some car factories like implement this, then the car price not exceed about 10 to 15,000. Whatever, if suppose the car price is 8 lakh, and if suppose the system is implemented in the car, then the car price is not more than 8 lakh 15,000. And the features which is available in Mercedes Benz or something like that, which is very highly, or like which is having a very high cost. So the system is basically for middle class cars.
Okay. Thank you.
Thank you, sir. Thank you very much.
Okay, Mr. Ved, I
Yes,
would
sir.
like to know one more thing,
Yes, sir.
that here you are using the sensors,
Yes, sir.
and with the help of sensor, you are making this smart car.
Yes, sir.
Do you have any software involvement in this?
Yes, sir, definitely. All the output of that sensor is given to the microcontroller, or like ARM7. And GSM GPS is not handled without software.
So
So
it has to be performed by the
software,
no.
sensor and software.
Okay, but your contribution is to develop the software to create an interface.
No, yes, sir.
So that part you have also
Like to show, sir. I'm extremely sorry that I just
you have not shown
as an
anywhere.
electronic engineer, I just show you all the electronic part actually. But there is a software, sir. There is a advanced C software, and with the help of using that embedded C software, all these things are interfaced.
Yes, hello.
Hello.
Can I ask a question to the presenter?
Yeah.
Yeah, okay. It is stated that he has the software and the hardware in his study or research. My question is, did he able to run this technology in terms of quality assurance, both in capability, maturity, model integration? Did he able to do that?
Yes, sir. Yes, sir.
Okay, what particular level in the CMMI you did what particular CMMI level were you able to use in your testing?
Sir, I implement this system. Hello.
Yeah.
Yeah, I implement this system like demo version. With the help of using demo, I just implement, and I'm not actually implemented this system actually in the car. I'm just implement in the demo car, whatever demo car, or for the demonstration purpose only.
Okay, so what was the result of your implementation in terms of evaluating it? Have you is it about prototyping, or you just a pilot test, or what did you use in terms of implementing it, and what's the result of it?
Sir, I didn't get your question actually.
Okay, you mentioned that you have this stage of implementation. So in terms of implementing the project, my first follow-up question to that is that did you able to work the result of your evaluation on that, on how you could be able to implement exactly?
Okay, yes, sir. I just compare the components. I just like this. I just perform the analysis of all the components, and after that, if suppose there are so many temperature sensors are there, but which is the best temperature sensor? I found that, and I implement that into my system.
Okay. Thank you. Very
Yes,
good.
sir. Thank you, sir. Thank you very much.
One more thing, Mr. Ved, I would like to know,
Yes,
have
sir.
you developed any prototype of this?
Yes, sir. I developed this prototype.
You have developed?
Yes, sir.
Okay. Because in your paper, you have only written this is the study.
Yeah, no, sir. Actually, this is study, but I implementing this in my college.
So you have developed the prototype.
Yes, sir. Yes, sir. Definitely
Okay.
developed. Yes, sir.
So we'll proceed further. Thank you so much.
Thank you.
Now I would like to call the next presenter, Professor Krishnakant Yadav, sir. Professor K.K. Yadav, sir, you could proceed. So K.K. Yadav, sir, would be shortly with us. So I would like to call the next presenter, Ms. Hilsha Mishra and Dr. P.C. Sharma.
आगे यदा सर आगे कौन कौन
Yadav, sir?
Yes.
Yes, sir.
Yes, sir. Thank you very much. Good afternoon. I'm sharing the screen.
Yes.
I already shared.
Okay, sir. Good afternoon, sir. Myself, Krishnakant Yadav. My topic is collaborative filtering based personalized recommender system. So basically, it is a review paper, a design of a recommender system. Next, please. Next slide, please. Recommender system basically focus on the two things: a user profile or customer profile, and second one is set of items or set of products which the particular user he or she like. So user profile basically consists information about the users, about the customers, and set of products or items includes the particular product. So recommend items user will like. The main purpose of the recommender system is the product or items which is user like. Set of items may be any news articles, books, music system, movies, any particular products, etc. Next slide, please. So personalization is the general idea that is user adaptive systems. So user profile consists, interaction is adapted based on data about an individual user. For example, personal websites, personalized tutoring, personalized recommendations about any product, etc. Next, please. So recommender system, everything is a recommendation. Basically, 2/3 of movies watched by Netflix customers are recommended movies. 30% of the click-through rates on Google News are recommended links, as well as 35% of sales at Amazon arise from recommended products. So basically, recommendation everywhere, everything is a recommendation. Next, please. So what is a recommender system? A recommender system or a recommendation system, sometimes it is also called a recommendation engine, is a subclass of information filtering system that seeks to predict the ratings or preferences. A user would like to give an item. They are primarily used in the commercial applications. Next, please.
Sige.
Next slide, please. In technical terms, we can say a recommendation system or a recommendation engine problem is to develop a mathematical model or objective function which can predict how much a user will like an item. For example, if user u equal to users and I equal to items, then f equal to objective function and measures the usefulness of item I to user u, given by f u into I tends to R, where R is the recommended items. So for each user u, we want to choose the item I that maximizes the objective function. Next, please. So there are different types of recommender system. Basically, recommender system is classified into content-based filtering technique, collaborative filtering technique, hybrid filtering technique. So as we know that the hybrid is the combination of content-based filtering and collaborative-based filtering. Furthermore, collaborative filtering is again divided into two parts: memory-based filtering technique and model-based filtering techniques. So they use different approaches, different techniques in the memory-based filtering techniques as well as model-based filtering techniques. So basically, we will focus on the content-based filtering, collaborative-based filtering, hybrid-based filtering. Next, please. Content-based filtering. A content-based recommender system works with data that the user provides, either explicitly or by the rating, or implicitly, that is clicking on a link. Based on the data, a user profile is generated, which is then used to make suggestions to the user. As the user provides more inputs or takes actions on the recommendations, the recommender system becomes more and more accurate. This is the content based. Basically, it is based on the rating or links, clicking on link. Next one is collaborative based filtering. A collaborative filtering is a technique that can filter out items that a user might like on the basis of reactions by similar users, or we can say past preferences. So it works by searching a large group of people and finding a similar set of users with taste similar to a particular user. It looks at the item that they like most and combines them to create a ranked list of suggestions. So basically, past preferences are also included in the collaborative filtering. And hybrid-based filtering is the combination of these two, contained and collaborative. So hybrid recommender system is one that combines multiple recommendation techniques together to produce the output. If one compares hybrid recommender system with collaborative or content-based system, the recommendation accuracy is usually higher in hybrid system because it uses both type of filtering, content-based as well as collaborative-based. Next one is demographic filtering. Demographic filtering also focus on some factors, for example, age, gender, profession. So they provides demographic filtering provides recommendation based on the demographic, like age, gender, profession, profile of the user. Recommended products can be produced for different demographic niches by combining ratings of user in those niches. So next one is knowledge-based filtering. It suggests products based on inferences about users' need and preferences, item selection, and its basis for the recommendations. Next, please. Basically, recommender system are based on content-based filtering, collaborative-based filtering, or combination of these two, that is hybrid-based filtering approach. If we take an example on movie data set, we have taken the data from the movie lens or movie data set in content-based and collaborative-based approach. Then we have in content-based filtering, we are seeing there are three columns: rating, user 1 preferences, and user 2 preferences. So based on the recommendation given by the user 1 in this category, here we can see easily see that that user 1 is highly interested in M1. So M1, movie 1, Avenger, that is the category of the movie, and M2, that is the category, adventure is the category of that movie. So we can say that user 1 is highly interested in M1 and M2 movies. Next, please, because it gives the rating of 5/5. Next is in the collaborative filtering approach, items or movie selection finds similar behavior or similar patterns and recommends items to users based on what other users want. In collaborative filtering approach, it is based on user behavior patterns, or just like a group of things. For example, in this column, in this diagram, here we have seen the user 1 have given good rating and user 2 have given good rating. So we can say user 1 and user 2 are of similar type. We can say user 1 and user 2 are of similar type. So for example, the Netflix, Amazon Prime are few websites which uses very great, although they are the example of also hybrid recommendation system. So we can say these are the few websites which uses very great use of collaborative filtering approach. Next, please. Now there are some basically issues in the problems in the recommendation system. Cold starting problem or cold start problem, data sparsity problem, synonymy problem, and many more problems. But these are the few problems which we have faced. So cold start problem or cold starting problem is basically refers to a situation where the promoter does not have enough information about the user or product or item to make appropriate predictions. So where the new user has added collaborative filtering is a way to personalize user recommendation from related preferences in the past. So that is the main issue in the cold starting problem, where user does not know the particular item which is added. Next one is data sparsity problem. So this problem often occurs when a customer check a limited number of products available, especially when the catalog is very long. Catalog is long, but the products is searching by the user is very short. So the output is a limited number of customers who have insufficient data. So this is generate or arise the problem of data sparsity. So here, limited number of customers who have insufficient data to identify such customers or assets, which affects the quality of the recommendations. Next one is synonymy. This is very much similar terms of the synonym. In the synonymy, this arises when an item is represented with two or more different names or entries having similar meaning. For example, suppose that in one example, a memory-based collaborative filtering approach that will treat comedy movie and comedy film differently. In such cases, the recommender cannot identify whether the terms represent different items or the same item. To elevate the problems of synonymy, different techniques including ontologies, the singular value decomposition, that is SVD techniques, latent semantic indexing, LSI, could be used. So these are the few. There are so many issues in the recommendations, problems in the recommendations system, but these are the few important problems arise in the while developing in the recommendation system. And next, please. Methods to use in a recommendation system. So there are so many applications, and so many algorithms are there. So our individual likes or dislikes are not used for custom suggestions. View the products which we might buy, even if we have never been on the website. Population behavior is the most important part of this. So population behavior can be used to guide suggestions. Other people like this, therefore we will probably like it too. So there are input X and output or target Y. Input X, user attributes will be included, such as name, gender, age, location, etc. And product attributes, screen resolution, particular RAM size, etc. Target Y will focus on the will we buy the product or not, or what will we rate the product, what are the different rating given by the other users or other customers or other particular person. And prediction can be used to rank or sort the items. So these are the few methods used in the recommendation system. Next, please. We can say, given a user and items rating matrix, one rating matrix is there. Here we have 6 user rows. Rows are representing users have rated 6 items, and 6 items are given in the columns. So ratings can take up integer value from 1 to 10. 1 to 10 we have a mark in the for rating, and 0. So 0 indicates absence of rating. The user has not given any rating to the particular product. So we have to find if the user number 5, user is basically representing rows and the product or items represent in the column. So if the user number 5 will like item number 3 or not, hence user number 5 becomes our target. user, that is our target user, or active user. We can say target user or active as, user at that time. And item number 3 is our target item. Next, please. Collaborative filtering based personalization method on the user needs. So user do not always leave behind enough personalized information, because that is personal information also included in the over the internet along their customer journey. For instance, new customers can be acquired, or existing customers might browse websites without being logged in. In the non-personalized recommendations, such as those based on proposals for products frequency purchased together, still offer recommendation opportunities for companies in this case. However, the more individually these are tailored to the customer, the better. Therefore, the personalized approaches are presented with learn the preferences of customers. To understand these methods, it is helpful to consider the recommendation problem at hand as a sparsely populated matrix. So the population matrix or the matrix user item matrix will be most important in such cases. The rows represent the users, the column represent the item. Whenever a user performs an action for an item, a respective entry is recorded in the given matrix. Otherwise, values remain absent and do not need to be explicitly stored. Sir, previous slide, please. The recommendation system can be used to produce the answers to precisely questions, such as to determine the unknown preferences of the customers of the of the items. Next. So conclusion is there. That conclusion is the purpose of this study is to design a decision-making system to develop recommendations for content based on collaborative filtering, taken into account the individual needs of the use. To achieve the goal, the following tasks are set. The following tasks will be followed. So first one is establish common operating requirements for system maintenance to develop recommendations for content that distributes commercial content on the internet. Second one is create a way to personalize economic content according to user requirements. Third one is develop software to distribute commercial space on the internet space based on collaborative filtering and machine learning systems. So the purpose is to develop either content-based or collaborative-based, develop the recommender system, which will give more recommendation, better recommendation about the previous history or about the past history of the user. So that is from my side. Thank you very much. These are the references.
Any questions?
Mr. Yadav.
Yes, sir.
You have mentioned here this recommender system.
Yes, sir.
So this recommender system can be used only to go onto the specific website of that organization, and then only user can give our choice.
User can
right?
give, yes, sir, yes, sir.
Choice. That is the purpose of this.
Yes, sir, definitely.
Okay. So it can handle only the data that is either of the past user or the current user.
Current user. Yes, sir.
Right?
Yes, sir.
So anyone who is aware about that organization can give our rating,
yes,
about
sir.
the product.
Yes, sir.
That's all.
Yes, sir.
Okay.
Yes, sir. That is the main purpose of the recommend. That's why, sir, it is recommendation. Recommendation about any product, everything, because system generate everything as a product, either in the format of movies, either in the format of books or anything else.
How your this system is better than the already available feedback system everywhere. Every organization is having that kind of feedback system, and that collects the quality of the product or services of the product from the user.
Sir,
so
basically,
how the system is better than the others that are already used.
Apply the algorithms, swarm intelligence algorithms or other advanced algorithms in this, so we can make more intelligent the recommender system. we can more give the values more intelligent to that system, so that can identify the product more easily and accurately rather than other systems.
So have you gone for the comparison?
Yes, sir, there are so many algorithms which we compare between these two.
Have you compared till now?
No, sir. No.
Oh, okay.
In this paper, there is no comparison. This is the review paper about the recommender system, so there is no comparison in this.
Then only that work has to be done.
Yes, sir. Yes, sir. Sure.
Then only we can say that our system is far better than the existing.
Yes, sir, definitely. There will be some algorithm as well as parameters by which we can say our system is much better rather than previous system. So new generations will be there.
That only can be after the comparison.
Yes, sir. After the comparison, we can see that this system is much better or this algorithm is much better.
It is just an idea that
yes,
you have floated.
Yes.
Okay.
Yes, sir.
Any other questions?
Yes, hello.
Yes, sir. Yes, sir, please.
Yeah, my question is, what particular or specific algorithm did you? What algorithm or what particular algorithm?
Sir, many algorithms are there. As we know that SVD algorithm is there. The algorithms used in the fuzzy logic or fuzzy systems or machine learning. So many algorithms are there used in the recommender system who give the more and more choices about any product.
Because one of your one of the conclusions or maybe recommendations that you have stated in your paper is that, correct me if I'm wrong, sir, you are going to develop a software. So if this software will be developed further with the recommender system, yes, what are some specific algorithms that your team or yourself will be used in your study or application?
Sir, we can use the swarm intelligence algorithms or other algorithms in this, and many parameters can be generalized with this. So we can say we can use this type of algorithms to make more intelligence the system.
Okay.
Yes, sir.
Yeah, thank you. Thank you for that answer.
Thank you. Thank you, sir. Thank you very much. Thank you, Sanjay sir. Thank you very much.
Thank you, sir.
Thank you.
Now we would like to proceed to the next presenter. So the next presenter is Dr. Nitin Tyagi. Dr. Nitin Tyagi, you could start with your presentation. Okay, so we'll proceed ahead and I'll call the next presenter, Samta Jain. Ms. Samta Jain, you could start with your presentation. Ma'am, can you hear me? Samta Jain Goel, ma'am. Okay, we'll move ahead then. Miss Hilsa Mishra, ma'am, you could proceed. Yes, ma'am.
Hello, everyone. Let me just share my screen first.
Yes, ma'am. Hilsa ma'am, you could share your screen. Yes, ma'am, you could share the screen.
You ask.
Ma'am, please unmute yourself. Can you hear me? Yes, ma'am.
I'm sorry. Now can you hear me? Am I audible?
Yes, ma'am, you're audible. Yes, ma'am.
The best features about India as a breeding ground for ICT is that it has humongous talent pool at incredibly low operational cost and works wonders using the remote delivery model. ICT is the integration of information processing, computing, and communication technologies. It can be considered as an umbrella of all the digital technologies. There was a major boom in India's IT industry since early 2000s, and now in 2020, almost 2 decades later, we have witnessed major innovations like broadband, e-commerce and cloud computing. In 1980s, when the emergence of LANs was taking the whole world by awe, in about a decade, the advent of optical fiber completely turned around the state of affairs. Suddenly, we could transfer data at the speed of light and actually see people sitting in other continents in real time through a computer. The world transformed to be driven by technology. Friends, that was an introduction of the title. Moving forward, these are the keywords: ICT, IT, transmission, storage, creation, collaboration, processing, displaying, and retrieval. The variables of the study are: ICT in the study is the second order construct, transmission, storage, collaboration, creation, processing, and retrieval are the first order constructs measuring ICT. This is the review of the literature. I have just put few important studies. Selected 9 countries have benefited from the positive effects of ICT capital investment on economic growth, according to Kolesia and Schreier 2001. Christina Brodar et al. 2009 posited ICT has significant positive impact on organizational efficiency. Koilinger in 2006 proposed that ICT and innovation are positively associated with turnover and productivity growth at the firm level. Noam in 2006 posited that volatility and cyclicality will be inherent part of telecom sector in the future. To deal with such instabilities, companies and investors see consolidation and cooperation, oligopoly, was predicted to emerge as the equilibrium market structure with some regulation to govern it. It is more relevant to the telecom sector. Next, Mukherjee in 2018 proposed that adopting AI, telecom operators will have the advantage to improve efficiency in network performance
Ma'am, Hilsa, ma'am, sorry to interrupt. Ma'am, you could just turn off your video so that I think some network issue is there. So then it would work smoothly.
I can open it.
Yes, ma'am.
Can I share my? Yeah.
Ma'am, can we share your PPT and then you could just present? Ma'am, please unmute yourself.
मुझे पूछो.
Ma'am, I think there's some network issue. You could just present and we would share the PPTs for you. So then the net would run smoothly. And we cannot hear you. Ma'am, we would share the PPT for you and you could present so that the presentation would go smoothly.
No, I'm sharing.
Ma'am, you could unmute yourself and start the presentation.
And off the video.
And ma'am, for better presentation, you could just off the video so it would consume less data. Ma'am, please switch off your video and you could unmute yourself and start with the presentation.
Not really.
I think your voice is not reaching over there.
Yes, I think there's some technical issue. Ma'am, can you hear me?
Yes, I hope that I am also audible.
Yes, ma'am. Now you're audible.
Okay.
Video.
Ma'am, for the better presentation, you could just turn off the video so the consumption of the data would be less. So that
Sure.
it would, yeah. Yes.
Since there were a few changes in the presentation, I would like to share it. Is it possible? Satish sir? Dr. Satish?
Yes, ma'am. Tell me.
Can I please share the presentation from my end?
Yes, ma'am.
Okay. I am getting this message that you cannot start screen share while the other participant is sharing.
No.
I guess you'll have to withdraw the presentation and then
This is the their screen. Ma'am, you can start. I am sharing a screen on behalf of you.
Right, sir. Actually, there is some difference in the presentation. That's what I messaged you.
But actually, some network issue occur from your side. That's why I'm sharing.
So let's try once again. I have
Okay.
my
Okay.
video off.
Okay.
So
Okay.
I think there should be no problem. All right, I hope everyone can see it.
Yes, ma'am.
All right. The study intends to fill the apparent gaps of dearth of studies exploring the concept of ICT, limited studies exploring the concept of ICT in Indian telecom sector, limited scope to single industry, and findings are not generalizable to the uh, broader population, and conspicuous absence of studies in Indian telecom sector, limited number of observations not sufficient for a substantial conclusion. That brings us to the objectives of the study. The main objective of the study is to study the different dimensions of ICT implementations in the telecom sector companies in India. The other objectives are to design, develop, and standardize measures for evaluating information and communication technology, and to open new avenues of future research. So the research methodology, the research design is basically descriptive because we are trying to describe every step we have taken, the methods in detail. The sample design is here as follows. Population, the executives working in the telecom sector companies in India. The target population is the executives working in the telecom sector companies in NCR region in India. The sampling frame is the list of executives working for the telecom sector companies in NCR region in India. And sampling technique used is judgmental sampling or purposive sampling. Again, tools for data collection, we have used a self-developed questionnaire, and tools for data analysis. Mainly, we have tested the reliability through Cronbach Alpha, and we have tested the validity of the measurement model through confirmatory factor analysis. So the types of data and data collection are here for you to see that we have collected primary data, and questionnaire is our instrument of collection, and we have also tested the questionnaire through the pilot study. In the study, as I have already said, that the primary data is collected from selected executives working with the telecom sector companies in NCR region in India. The primary data was collected from executives with different designations, experience, and departments, etc., with the help of self-designed questionnaires. And it was collected both online and offline. The questionnaire framed in the study was designed in different stages. The process started from extensive literature review, discussion with industry experts, and conducting interviews in order to understand the key variables of ICT and workforce planning. The key variables are converted into statements in order to include them in the questionnaire. The draft questionnaire is further discussed with industry users for content validity, and the draft questionnaires were refined and further modified during the pilot survey. During the pilot survey, few problems were encountered, such as overlapping of statements, problem with the language, explorations of new dimensions, etc., due to which the questionnaire is slightly modified further for final data collection process. The questionnaire was finalized after removing few duplicate statements and adding new statements after the pilot survey. The language of the statements is also modified at this stage. Finally, the questionnaire is ready for data collection in order to achieve the objective of the research. So these are the softwares that we have used, MOS 21 in addition with SPSS 21 for statistical data analysis. So now that brings us to the CFA diagram of ICT implementation. So these are the first order constructs: transmission, storage, creation, collaboration, processing, displaying, and retrieval. We can see these bidirectional arrows which signify the correlation or the covariance between the factors. These are the factor loadings, that is the relationship between the factors and their measured items. And this is the error associated with every item. So then in the result, we had the table that indicated the regression weights. So the contents of the tables were the standardized construct loadings, unstandardized regression weights, standard error of unstandardized regression weights, the critical ratio estimates and their probability value. That brings us to the results of this study. The results indicate that all the standardized regression weights are found to be greater than 0.7. The higher value of standardized construct loading indicates that all the statements included in the study represent their respective dimensions significantly. In addition to this, the standardized construct loading greater than 0.7 also represents the presence of convergent validity. In this scale, used to study ICT implementation in the Indian telecom sector companies. The results also indicate that the probability value of critical ratio in case of each statement in the measurement model is found to be less than 5% level of significance. Hence, it can be concluded with 95% confidence level that the considered measurement model consists of significant statements which are able to measure their specific dimensions. Now we come to the correlation analysis, correlation between the different dimensions of ICT. So the result of correlation analysis indicates that all the estimated values of Pearson correlation between different pairs of dimension is positive and moderately strong. Hence, it can be concluded that all the dimensions indicating the ICT implementation are found to be positively correlated. Next, we come to the statistical analysis, which covers two estimates, the statistical estimates of the dimension of ICT and the statistical fitness of dimensions of ICT. Let's come to the first. So these are the most important factors, the most important estimates that have been given in the table. The CR estimate of each dimension of ICT implementation is found to be greater than 0.8. The AVE estimate of each dimension of ICT implementation is found to be greater than 0.5. And we can easily observe that the AVE estimates are more than MSV estimates, which is the proof that there is the presence of discriminant validity also. Coming to statistical fitness, the results indicate that C-min by DF value 1.556 is found to be less than required value of 5. The GFI 0.861 is found to be greater than required value of 0.8. The CFI 0.966, TLI 0.964 and NFI 0.911 are found to be greater than the required value of 0.9. Finally, RMSEA, which indicates the badness of statistical fit, is found to be less than 0.08. With that, I would like to conclude the study. The study examines the ICT implementation dimensions in the telecom sector, in the telecom industry considered in the study. Data was collected from various companies in the telecom industry in Delhi NCR, and after establishing the reliability of the instrument, I'm sorry, I'll correct that. CFA was used to test the measures of the construct. The underlying factors are extracted and tested to be found positively correlated. We successfully developed a standardized measure for evaluating information and communication technology in Indian telecom. That would be all from my side. Thank you so much.
Thank you, ma'am. Questions? Any questions? Sanjay sir, Dean sir. The floor is now open for questions. Sanjay sir, Dean sir, or any other participant would like to question?
Ilsa,
Yes, sir.
which tools you have used for the statistical analysis?
Tools used for statistical analysis. Sir, I have used MOS.
Why?
Sir, why I have used MOS? Sir, there is Lizrel also, but MOS was available with me. Usually I conduct studies with SPSS and MOS only. So that was the reason. And
so your work of your study work, what significant message it gives?
So the significant message is that we are trying to measure the ICT in telecom sector, and these dimensions are doing justice. I mean, justifiably, they are they are the factors to measure ICT.
Any implementation, any further implementation guidelines comes from your work of study?
So with this, after once we have finalized that these are the factors of ICT, we can study the impact of ICT on various aspects of the organization, on organizational efficiency, on workforce planning, on HRM, on various other aspects of the organization. Once we have, this can be considered as one part of the studies that can come. It can become a basis.
Right. Because I have not seen any concrete output in your study.
Yes, sir.
That's why I am asking.
Sir, can we please repeat?
I have not seen any concrete output from your study.
Sir, actually, it is part of my thesis work, and my thesis was titled "The Impact of ICT on Workforce Planning in the Telecom Sector in India." So this is objective, the first objective, to study ICT, the factors of ICT.
Okay. So if I may bat in, well, I have a very significant question about your study. Which among different implementable ICT infrastructure in telco in India has the most demanded approach? Which among those technology or ICT infrastructures has the most or the highest level in terms of demand or functions or usage? Can you identify it?
Yes, Pastor. When I completed my study, my thesis work, what I could gather was there were certain dimensions of ICT that were more comparatively more important as far as their impact on workforce planning is considered. So, if I look generally, I mean, in the telecom sector, what are the more prominent dimensions of ICT? I guess that since no other industry works in a full force with so much geographical distances, because telecom is all about uh, communicating in real time and without thinking about how distant we are actually. I mean, having this conference, the way we are having is mere proof that the telecommunication is working. I mean, the ICT is working. So I guess that
Yes.
transmission is the most powerful aspect of ICT. Yes, there is processing, yes, there is storage, creation, collaboration, everything is there. But if we cannot transmit at this speed, when we can see in real time, when I'm moving my hand, I'm sure everybody can see it. So we can talk and see in real time. So that is the strength, and that is the biggest achievement of ICT.
Okay, my follow-up question is, um, we all know that ICT is a very broad term, no? Information communication technology. It
Yes.
could be a combination of hardware, software, and different platforms, no? So, in the implementation of ICT in the telcos in India, uh, how can you give us the percentage in terms of software implementation and hardware implementation in telco? What is greater than what is more higher, the higher the hardware or the software implementation?
Pastor, I guess it's both, because see,
Okay.
hardware, I mean, they go hand in hand, because the software cannot work without a robust hardware, and the hardware has to be aligned for better software performance. That's how we can, I mean, the examples are the kind of phones that we are using today. They are the perfect examples of how smart the hardwares can align themselves, and how user-friendly the softwares are, we never realize, but they are also equally aligned in the sense it is a seamless experience. When we use it as if it is extended part of our anatomy. I hope I am able to answer you.
Okay, thank you so much.
Thank you, Pastor.
Thank you.
Thank you, sir. Thank you, ma'am. So with this, we have moved forwards towards the end of the session. But before that, this is the last call for Samta ma'am and Nitin sir. If anybody is left for the presentation, could just start with their presentation. Else, we'll proceed towards the ending session. Okay, so I think then we'll wrap up this session. And with this, now I would request the co-session chair, Dean Pastor Aglas Jr., to give his valuable feedback about this session. Please, sir. Dean, sir?
Yes.
Yes, sir.
Well, of course, I would like to congratulate the organizing committee, of course, and all these presenters this afternoon, and wish you more luck and God bless everyone. Thank you.
Thank you so much, sir. Now I would like to call upon our session chair, Professor Sanjay Gupta, sir, to share his views and feedback about today's technical session. Please, sir.
Okay. Good evening to all of you. My colleague, co-session chair, Dr. Poscher Jr. and today's speaker, Dr. Kudu Khose, and faculty members, dear participants. You have done some work and presented 4 papers in this conference, and out of them, I have seen most of the participants have done your work related to collection of the data. First participants, which is Shashi Sharma, have done the review work. So that has not been included any implementation or either concrete data. Others have collected data and also move forward to implement the problem. So 2 aspects of research is identification of the problem, identification of the data, and implementation of the data, solving the problem and finding the results. So in this direction, I have seen some gap. Okay, but all of you have done some positive efforts, and I hope in future you will be more aware, more careful to present the paper. All the best to all of you, and thanks to the organizer for inviting me to participate in this conference. Thank you very much.
Thank you so much, sir, for your kind words. Gratitude is the best attitude, they say, and to thank all our panelists for their valuable time and knowledge they shared with us. Thank you so much, sir. Now, may I request Professor Satish Bansal to propose vote of thanks. Please, sir.
Very good afternoon, one and all. I, Satish Bansal, feel honored and privileged to get an opportunity to propose a vote of thanks in this Information Technology Technical Session 8. I, on behalf of Prestige Institute of Management Gwalior, convey deep regards and hearty thanks to our session chair, Dr. Sanjay Kumar Gupta sir, who gave the valuable time and his gracious presence beneficial and motivate for us. Thank you, sir. I express my gratitude to our co-session chair, Dean Foster Argler Jr., his presence gracing and enlightening this session. Thank you very much, sir. I express my thanks keynote speaker Dr. Utku Ghosh, his support and cooperation always with us in future. And he gave very good area artificial intelligence. Thank you very much, sir. I convey thanks to all distinguished participants and research scholars who have come from different places to attend this session. I also thanks to our director, sir, Dr. Hashish Bhakar, sir, who always support for such kind of the event. Without him, it is not possible to conduct such event. My sincere thanks to print and electronic media for their presence and giving excellent coverage for this workshop. My special thanks to all faculty and staff members for their immense support and cooperation. Last but not least, thanks everyone who directly, indirectly support for this workshop. Thank you. Jai Hind.
Thanks. Thank you very much.
Thank you so much, sir. Now we would like to end the session. Before that, thanks to all the panelists and the participants. And also a big thanks to our sponsor, SBI. Thank you, everybody. Thank you.